Hello and welcome to my YouTube channel Plastic Industry. Today's topic is something amazing. We will talk about plastics. There are amazing facts about plastics. For example, do you know that's a plastic that can absorb 100 to 1000 times its own weight in water? Yes, it's real. It's science and it's saving lives, cleaning the environment, and even powering agriculture. Don't believe? Let us dive in and find out as to why I am making this statement. Welcome to the world of sodium polyacrylate, also called super absorbent polymer, SAP, the magic plastic that drinks water. By the end of this video, you will understand how it works, where it is used, from baby diapers to high-tech agriculture, and why it might shape the future of sustainability and clean technology. Let us focus on Chapter 1. What is sodium polyacrylate? Sodium polyacrylate is a super absorbent polymer made by polymerizing acrylic acid with sodium hydroxide. Chemically, it's a cross-linked polymer chain that traps water molecule inside, forming a gel. Imagine tiny sponges at a molecular level. That's sodium polyacrylate. Each granule swells as it absorbs water, locking it in so tightly that you cannot squeeze it out easily. The ability to retain huge amounts of liquid is what makes it a revolutionary material across many industries. How it changed baby care forever. Before the 1980s, diapers were thick, heavy, and uncomfortable. Then came sodium polyacrylate. Just a few grams can absorb half a liter of urine, keeping babies dry for hours. That's why almost 100% of modern diapers and adult incontinence products use the plastic. It revolutionized comfort, hygiene, and waste reduction. A silent innovation billions depend on every day. Chapter 3. Farming water. Yes, really. Farmers are now calling it water insurance for crops. When mixed with soil, sodium polyacrylate stores rainwater and releases it slowly to roots during dry spells. This is crucial in drought-prone regions. Just 1 kg of polymer can hold 200 to 300 liters of water, reducing irrigation frequency by 50%. It is used in India, China, Israel, and Africa for smart agriculture, saving water, boosting yields, and reducing costs. So let's move on to Chapter 4. How it saves lives in disaster relief. In flood relief camps or hospitals, sodium polyacrylate is a lifesaver. It is used in medical absorbent pads, wound dressings, and instant cleaning solutions where hygiene is critical. In disasters, it helps manage liquid waste and biofluids, preventing contamination and disease spread. The simple plastic simply supports humanitarian missions worldwide. Let's have some fun. Take a teaspoon of sodium polyacrylate found inside diapers, pour water, wait 5 seconds, and flip the cup. Surprise! No water spills. It's now a gel. Surprise! No water spills. It's now a gel. That's because the polymer chains trapped the water inside. Teachers use this to demonstrate polymers and cross-linking in chemistry class, a great way to make science fun. Move on to chapter 6. Plastic industry impact and manufacturing. India's domestic market for super absorbent polymers is growing fast, projected at over rupees 2,500 crore by 2030. Still, more than 80% of sodium polyacrylate is imported from China, Japan, and the US. Manufacturing involves polymerizing acrylic acid in a water-based medium with cross-linking agents, followed by drying and grinding into powder. There's massive scope for Make in India investment here, especially for diaper, hygiene, and agriculture grade SAPs, super absorbing polymers. So now in chapter 7, can it be recycled? That's a big question. Recycling is tricky. Sodium polyacrylate is non-toxic but non-recyclable in conventional plastic systems. However, researchers are developing biodegradable SAPs from starch and cellulose, which could replace petroleum-based versions. This could turn super absorbent polymers into eco-friendly water savers instead of waste creators. Now in chapter 8, future applications. Next generation innovation include smart wound dressings that deliver medicine directly to wounds, cooling fabrics using water absorbing polymer, hygroscopic electronics to protect devices from humidity, hygroscopic electronics to protect devices from humidity, hygroscopic electronics to protect devices from humidity, hygroscopic electronics, artificial snow, and gel-based batteries. In short, one polymer, infinite possibilities. Smart wound dressings that deliver medicine directly to wounds, cooling fabrics using water-absorbing polymers, hygroscopic electronics to protect devices from humidity, artificial snow, and gel-based batteries. In short, one polymer, infinite possibilities. So from saving babies to saving water, from the lab to the farm, sodium polyacrylate proves that not all plastics are villain. Some truly make life cleaner, safer, and more sustainable. Innovations surprise you the most. Until next time, this is Amitabh Sanyal bringing you science that shape our world. Thank you.